Now, we've dealt with few evolutionary optimization algorithms. That is one of the branches of AI. Now we start with machine learning. So before we go ahead with machine learning, we need to know what is the role of machine learning in artificial intelligence. Is it artificial intelligence or are they interchangeable? Where does machine learning lie in the corridor of artificial intelligence? So let's see that. Now, you can see over here, there are broadly 7 branches of artificial intelligence. These 7 branches are rule-based systems, which basically indicates fuzzy logic or fuzzy if you're trying to implement fuzzy systems. Then you have planning, scheduling, and optimization, which includes meta heuristics like simulated annealing, taboo search, genetic algorithms, particle swarm, for planning, scheduling, and optimization, basically. Then you have speech, where you convert your speech to text. You have seen the applications of speech to text and text to speech, right? In PDF, there is in Acrobat PDF Reader, there is functionality of that where you can read out a PDF without actually reading it out by our eyes. And then you have speech to text where you speak something. You have applications where you speak and it converts that into text. Then you have machine learning, which has several components: supervised learning, unsupervised learning, reinforced learning, and predictive analytics and deep learning. There are plethora of techniques in predictive analytics and deep learning. Like in predictive analytics, we've done regression, we've done we'll be doing k-means, Bayes classifier, many other things. And deep learning starts with the neural network and then goes ahead. Then you have natural language processing, which is translation, information extraction, classification, and clustering. Then in vision, we have image recognition and machine vision. So you see that those applications in cameras a lot. Then you have robotics, of course. So artificial intelligence is a very diverse field, and the applications are you can see now the applications are pretty large. However, in this course we have limited our discussion largely on planning, scheduling, optimization, and machine learning, because being an industrial engineer, these are the main areas of application which we find. Now something about progression of machine learning across decades. You can see in 1950 was the first thing when Alan Turing devised learning machine, and then subsequently in 80s, recurrent neural network was used for the first time. And then commercialization of machine learning, it's not something new like 3 or 4 years back. It's the commercialization has been there in some or the other form or the simpler forms since 1989. Then 1995 support vector machine algorithm was devised. So we're going to do that in coming lectures. Uh, IBM Deep Blue beats world champion Gary Kasparov. So they say that they attribute it to machine learning again. Then Netflix first machine learning competition in 2006. In 2010, Kaggle was launched, where a lot of data is available on Kaggle. So because of the availability of data, people can now use different algorithms, different techniques, and then it's now happening. You know that. So what is a machine learning? A computer program is said to learn from experience E with respect to some class of task P and the performance measure P. So there are basically 3 things which are involved. Experience, that is the data. Performance measure is the output, and the task uh, is the process. Okay. Uh, yeah. So how do they learn? There is an input data. There is abstraction, which abstraction you can understand. It could be mathematical abstraction. It could be other analytical abstraction. It could be some logical abstraction, and then it leads to generalization. That if this is the scenario, this scenario would implicate what? That's what it means, generalization. So three different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, you have classification and regression. Uh, you have seen that, like, if I tell an algorithm initially with the training data that if a certain data is exhibiting these attributes, you can label this data as apple and orange, something like this. So that is supervised. You already give initially some output or the expected output, and it learns from that. So it is a supervised learning. So basically has classification and regression. Then you have unsupervised learning, which is clustering and association analysis. So association analysis would involve decision trees. Clustering has a different application where you don't tell initially that what these, like, principal component analysis is there, where different labels are available, but you different outputs are available, but you don't give them names to the output, or you don't give them a class. It automatically gets aggregated. So that's unsupervised learning. And reinforced learning, you can say it's something like a neural network, but it progresses from there. It's exactly not neural network. So in supervised learning, you have this predictive. You're predicting on past experience. It predicts the class of unknown objects based on prior class related information of similar objects. So prior class basically means that already a priori it has been told what class does it belong to. So then you're learning on it. So classification is predict categorical or nominal variable. Uh, I'll be uploading k-means clustering also, and later, but then you have regression, predict a real valued variable. Typical problems of classification and regression are like image classification. Uh, this image, let's say, uh, you take a photograph of a certain thing, a certain person. Now, how does the camera tell whether it's a male or a female? You must have seen that function in your mobile phones also. So that comes over there, image classification. Prediction of disease, mm, by looking at the cells. I've talked about that earlier in the class. Win-loss prediction of the games. So that's again classifying. Like, if these are the set of people playing based on their mm, past records, uh, and if that's how the game is progressing, whether they're going to win or lose, it's again a classification problem. Recognition of handwriting. There are certain applications which come when you write on a tablet, then it converts that into a Word document. So that is recognition of handwriting. Again, a classification, because, or captcha which you have online, right? When you're filling out a form or logging in a bank portal, you see that captcha. So that is again a recognition of handwriting, because it's whatever is written over there, it's not exactly in a very straightforward format. So you have to write that in a box, and then that's recognition, whether this is A or this is E. Okay, so it should be able to distinguish between the two. And regression, you already know, so I need not tell you again about it. So classification is somewhat like this. I think these we've already done earlier. So you can see here there's a labeled training data. So you can see that 4 people are there. Their characteristics are given and the class is given. So this classifier, KNN classifier is there. So it uses that. So which class does this belong to? If his name is Josh and aptitude is 5 and the communication it is 4.5, whether it goes to a speaker or an intelligent class. So that's what it's. And then you have regression. So I'll not focus on that. Unsupervised learning. So unlike in supervised learning, here you do not tell whether the student is speaker or intelligent, something like this. There is no labeling of the training data. Your objective is to take data set as input and try to find out natural grouping or the patterns within the data. Okay, so also known as pattern discovery or knowledge discovery. So you have like triangles, squares, spheres, and circles. So, but you're not telling the data set that this particular object over here is a rectangle. It has to do it on its own. So it classifies them into 4 different categories, and it is on you to give the name to that now. Then you have the reinforced learning. A machine learns to act on its own to achieve the given goals. Just like babies learn to walk without prior knowledge on how to do it. So it's like through experience. It's some tasks are performed and the labels are created and the performance is measured. So in supervised and unsupervised learning, performance is not the criteria. But in reinforcement learning, performance is one of the criteria which is used for differentiating. So like walking. So a kid will know that at what angle, with what weight, with what inclination he should get up so that he does not fall. But that happens over a period of time. Like here, performance would be a kid trying to get up for the first time. He falls down. So it gets registered as performance not good. So you need to improve upon the performance. So that's how a kid does it. So that's what it is called reinforced learning. Like performance has to be improved every time. So whatever the value of input variables you are taking, it should affect the performance, and the performance becomes relative over a period of time. That earlier this was the step, the performance was this. Next time the next time the input variable values are these, the performance is relatively better or worse. And then we keep on doing things and then keep on registering or star marking where the performance is getting better, and we pick up those points and keep it separately, and then we keep on iterating. That's called reinforced learning. So you can see over here reward is kind of a performance, and yeah. So if you like to differentiate between the three, supervised learning is used when you know how to classify given data. That means you have the output. Unsupervised learning is used when there is no idea about the class. How many classes does exist? How many classifications are there? Or you don't know how to name them. Reinforced is used when there is no idea about the class or label of particular data. So you at times there might be tie between unsupervised and reinforced learning. Uh, so reinforced learning is a bit more complex algorithm. The algorithms are a bit more complex in reinforced as compared to unsupervised. Labeled training data is needed in supervised. That means you should know the output. Any unknown data and unlabeled data set is given. But at least you should have some idea that is some classification existing in the data. In reinforcement, model learns and updates itself through the reward. There are 2 types in supervised: classification and regression techniques. Uh, Again, in unsupervised, you have clustering and association techniques. Some of the examples in supervised are naive bias, KNN, decision tree, linear regression, logistic regression, and support vector machine. Later, I'll be uploading some videos on naive base, KNN, decision tree, logistic regression, and support vector machines. So you can go through them. While in unsupervised, you have k-means clustering, principal component analysis, and a priori algorithms. While in reinforced, we are not going to do reinforced learning in this course. We have Q-learning and SARSA. So we're not doing in this. We're just sticking with supervised and unsupervised learning. So that's it for today. I hope you read it.